Okay. My last question was around the validation challenges that people are having with regard to AI and AI adoption, particularly as it relates to cloud analytics providers. I was wondering if you can comment on the validation, some of the validation implications, and some of the ways that people are using to mitigate those validation concerns.
So there are two aspects to validation, right? Whether you do it with cloud-based systems and AI-based analytics, or the way we are doing it with an on-premise system and the methods that we use. So one is the CSV, computer systems validation part, which has to do with the software and its behavior and data integrity, et cetera. So that should be addressed by the analytics provider, right? I'm not trying to preach or promote the method because we provide an analytics platform. So in general, if you stitch together your own system using managed services which are available in the cloud, you're making your life more difficult, right? Because you still will have to do through those CSV methods, right? So one recommendation is if you're using a containerized system, so a containerized system will very well, because if you look at the FDA, after cloud-based systems came out, has not come up with a new CSV protocol, right? So you're supposed to apply the same CSV protocol, whether you're doing it on an on-premise server or on a piece of software in the cloud, right? Now, if you go with too many managed service pieces that you have stitched together with DevOps, you are making the CSV task bigger and longer and more time and cost expensive, right? But if you go, so it's about defining your analytics platform as a deterministic package, just like you do with on-premise software, and the way to do that is through containerization. So if I have a well-defined container, and I, as the supplier, just like you expected that when you buy a control system or you buy an OSI Pi system where the supplier gives you the CSV protocol, I can provide that CSV protocol so long as my container doesn't change, and that works. So that's how you make the CSV part easy. The second part is the GXP validation, which is about controllability and control parameters and deviations, et cetera. For that, if you would use the same validation protocols you have internally. So if now, I generally speaking, a lot of work in deviation analytics, controllability. We've been using MSPC. We've been using SPC for a long time, right? So fundamentally, inherently, except for deep learning, most machine learning is founded in statistics as well, right? So I answer the same question when people ask me the question, how would I validate if I use a machine learning model? I'd say, how do you validate when you use SPC? You would use the same methodology, and the methodology you have your written procedures about how you do your internal GXP validation when you make a change. You follow the same protocol. Yes, now you should expect the analytics system that you use to give you the provisions to be able to follow that. Things like change management, audit trail, et cetera, should be there so that it's easier. So I think maybe there is more fear about it will be harder than it is. And also, I think when you use, because a lot is possible with managed services, you can, from any one of the hyperscalers, you would say, I can use this service to do that. If you start doing it, I tell people, if 10 years ago there were tools available with which you could build your own process control system, would you build it? No, you went and bought a process control system because somebody had done the due diligence to make sure it would meet those requirements. So when you use that approach, and that happens with containerized systems which have their own version controls, which is the responsibility of the vendor who supplies that, to say, for this version, I have made certain changes which require you to revalidate the system. The onus is on the vendor. So if you follow those same steps, it's not any more difficult than it was with on-prem systems.